it launches us into the MySQL terminal monitor, which is an interactive interface to work with the DBMS engine. When you connect, it tells you that you are in monitor mode, and it also tells you your connection ID, the version of the server, how to get help, how to clear a buffer, and you should end your commands with what you see here, and or \G is the escape sequence. And typically you end your commands with semicolon, which is what's reflected, although it looks like a colon. So we're in this terminal monitor. This is a client-server connection that's open, but we should set the permissions first and then use the terminal monitor. And to do so, we can take advantage of either set password or the MySQL admin utility. So let's give you the syntax. That's going to be MySQL admin. For the user root, we'll set the password, let's say to ABC123, just so that it's no longer the default blank password, which will force users to authenticate to connect to the daemon. So to quit, we can type exit or quit, and we'll propel to the shell or reverted to the shell. And now we'll execute MySQL admin to set the password. And that has worked for us. Now, any of these utilities can be executed with the help option. So MySQL help returns the myriad options that are supported. Additionally, for each MySQL command, as we earlier mentioned or alluded to, the printout of the order in which configuration files are read is available. So this tells us that when you execute MySQL admin, it first parses directives in the global etc my.cnf file. It will then search the user's home directory, the currently logged in user's home directory, for a hidden my.cnf file. And then last but not least, it'll search etc my.cnf. You scroll up towards the top and you'll see the general options that you may use with MySQL admin. And there are many options. Iterations, whether or not you'd like to compress the connectivity between the client and the server, indicate a password for connectivity, change the port, set variables, connect using SSL, you name it. There are many, many options supported. But the admin utility goes beyond just those simple options of influencing connectivity. You can create databases, for example, by indicating MySQL admin, your credentials, followed by create database, or create space database name. You can flush. In other words, many of the things that you can do from within Terminal Monitor or from within the GUI environment to manage your DBMS, you can do using MySQL admin. Flush privileges, kill a process ID. Maybe you have a process ID that's using up the resources of your server, overwhelming it, change the password of a user, ping the server to see if it's alive. So for example, MySQL admin ping attempts to ping the localhost, but unless you indicate credentials, it returns an error. So you indicate root followed by P to prompt for password, and then after you've indicated the appropriate password, MySQL admin performs the equivalent of a ping to determine if the server is up and running, and whether or not you'd like to shut the server. So for example, let's say that is desirable, indicate shutdown, and this will actually shut providing we authenticate. You can also authenticate using any MySQL utility by indicating the password immediately next to the P option or juxtaposed to the P option. So we know the password is ABC123. This will shut the server for us without prompting us for a password, and momentarily the server will be down. When we psef grep MySQL, we'll see the instance no longer exists. And if we follow this up with status instead of shut or shutdown, it'll tell us that the server is currently not running because it's unable to talk to the Unix domain socket, which is accessible via varlib MySQL mysql.sock. Let's go ahead and service MySQL dstart to get it back up and running. And again, when the server starts, it maintains files beneath varlib MySQL, including its default databases, a socket file, and InnoDB log files. So again, MySQL admin provides you with various options that you may use to get a sense of what's going on. Let's take a look at the current process list on the local instance. We'll change this to process list, and it returns a tabular format of the current processes. And in this case, we saw ID2 for a connection that MySQL admin made to ascertain the process list. So basically, the admin utility logged in or passed into the MySQL database show process list, which showed up as a connection. If, for example, from a separate shell we connected, let's do so using the user root and password ABC123. So this has assigned to us connection ID 3, and then from the other shell we rerun process list. You'll now see both shells, or both sessions, that is, both MySQL shells or terminal monitor instances. One executed show process list, the other one is currently idle because there were no processes being executed or queries being run. So it reveals the current connections, and the admin utility is a front end to different things that you may do on the server. So primary admin utility to return useful info and perform admin tasks from the shell. Great, now the server is up and running. Let's do one other thing. Install, just to illustrate connectivity from across the wire, the MySQL client on a remote system, and then test connectivity to our instance. So again, on the remote Red Hat Enterprise or the local Linux CBT Serv 1, we'll use yum-y install, since the repository is set up, MySQL. And then we'll attempt to connect. So let's navigate to a local shell that's available. Here's one. And this will install the client momentarily, at which point we'll then use the client to connect. So to connect, step B is to simply execute MySQL u root prompt for password, optionally indicate the password on the command line, but it's generally not a good idea as it will remain in the history of the user's shell. So we'll just be prompted, followed by the server name, which we can indicate, and let's just take a look to see where we are. This has been installed. So again, if we execute MySQL with the help option, you'll see the myriad options that may be run. These values that you see here are set based on global and or local configuration files. So there are defaults that are set for all of these items, such as which database should be a default, whether or not compression should be enabled, whether or not a local in file, an input file from a text file is supported for importing data, so on and so forth. But above that, you'll see the different options that pertain to connectivity to a remote system and or a local system, including whether or not SSL should be used, compression. These settings that you see above the defaults, when indicated on the command line, overrides anything derived from a global configuration file. So that's something we should note, just so that you have that in mind. So you execute MySQL optionally with options. That's what the brackets mean, that the options are optional. And these options override anything derived from a global or local configuration file. So note, MySQL command line options always override global, which means etc my.cnf, and or local, which means user's home directory, hidden my.cnf, configuration, directives. However, the MySQL client that's in use will always display a list of directives that have been derived from the global and or home or user-based configuration file. So it'll always at least set up a set of directives and options defaults that it will use to connect a remote system, and it's up to you to then override those options when connecting to a remote instance. I'm just scrolling through the options here so that you get a sense for some of the things that you can do with the client when connecting to a remote instance. So again, these are the defaults that are set. So from the remote system, we want to connect, or from this local system, we want to connect to the MySQL instance running on a remote system. On a remote system, a good thing to do is confirm socket-wise, TCP-wise, using netstat, that MySQL is reachable. So netstat ntl grep, and the port is 3306 on TCP. It is reachable because it's bound to all IP version 4 addresses, whereas in a more secure setting, 3306 may be bound to the loopback adapter. So with that said, we should be able to connect from any remote host, providing we have the appropriate credentials. So let's go ahead and give this a try, and you'll see momentarily that it will fail because by default, you are unable to log in from a remote system as the predefined users. Let's try this to show you what we mean. MySQL, the user's root, will be prompted for a password, and the hosts will be 192.168.75.199, or the FQDN or short name. It prompts us, and we'll enter ABC123, but you'll see that the host .10 is not allowed to connect to this MySQL server. So it knows the server is there. However, it doesn't allow us to connect. Now let's show you why that's the case. From either of these shells, since we're here in a terminal monitor, let's show databases, which is a standard SQL command. It includes a schema, MySQL, and test. Let's then use MySQL. And by the way, use is one of the few commands that doesn't require semicolon. We'll then show tables, and this database contains an important table, the user table. The user table stores the users who may connect to, so it's an auth table, who may connect to the server. And users in MySQL consists of a username part followed by a hostname part. So with that said, let's select star from user, and if we scroll up, you'll just see that for each user instance, root for example, there is a field which stores the host that user root or the username may connect from. So root may connect if connecting from localhost, and root may also connect if connecting from Linux CVT serve 4.linuxcvt.internal, but root may not connect from other hosts. These other items you see here are for anonymous connectivity. By default, MySQL permits anonymous connections. Limited access, of course, but nonetheless, it's still a security concern. Let's go ahead and just note MySQL users consist of the following. A, username, i.e. root. B, host, i.e. localhost. And together, both form the full username. So, a sample username is root at localhost. And the server parses both parts separated by the @ symbol to determine whether or not the user is permitted to connect to the server. So in order for the user from the .10 host, that's this local system, to be able to connect to this .199 host, we need to create a user named root, if that's who we'd like to connect as, at the IP address or FQDN, or create a root user who's permitted access from any host. So that's how you need to look at permissions within a MySQL context. It's based on both the username and the hostname part, and the server makes that determination, because when you connect from a client such as 192.168.75.10, this IP address, and optionally the FQDN, which is tied to this IP address, is supplied to the MySQL server. So the server knows who you are because the client supplies that information to the server, so that the server can make the determination as to whether or not you should be able to connect. Now let's move forward. We have a fourth task, and that is to secure the environment, secure the anonymous environment. So we'll secure anonymous account. And really the only way to do so is, or two ways to do so, is to either set a password for anonymous, if you'd like anonymous access to remain, or delete the anonymous account altogether. We suggest you delete the anonymous accounts using delete from standard SQL statement, mysql.user. This is standard SQL statement to mean db.table name. We need a where clause to set our criteria.